So this lesson, we're talking about graphing and functions. Basically, we're going to start with the, coordinate system. We're going to talk about different parts of the coordinate system. Except I want you to cut off the bottom and save the discrete and continuous graphs. We're going to do that for the next lesson. So that's why I cut that off. But first of all, we're talking about the coordinate plane, okay? Now, parts of the plane, we're going to talk about the origin, we know as the point 0, 0. And the quadrants, we label starting at the top right is quadrant 1, and we just use Roman numerals, and we go counterclockwise. So then quadrant 2 is the top left, and then the bottom left is quadrant 3, and we go around to quadrant 4 is the bottom right, okay? We know the x-axis is going to be the horizontal axis. It's like the number line that we've been graphing all of our inequalities on. And the y-axis is a vertical number line, and we just label it y. But different from what we've been doing, we're going to be doing both x and y's when we graph. So any ordered pair, the first coordinate is your x and the second coordinate is your y. So for example, and actually let's go back here. If you look in quadrant 1, all the x's, since we're to the right of 0, and all on the y is above 0. So in quadrant 1, all the x's are positive and all the y's are positive. So every point that belongs in quadrant 1, both x and y are going to be positive. Quadrant 2, you see the x is going to be to the left of the origin, so the x's are going to be negative, and then the y's are still above the origin or above 0, so they're still going to be positive. Quadrant 3, you can see both the x's are to the left of the origin, so that's to the left of 0, so they're negative. The x's are negative, and all of the y's are below the origin or below 0, so they're also negative. So we call that the negative quadrant, where both the x's and the y's are negative. Then quadrant 4, you see that the x's are to the right of the origin or to the right of 0, so all the x's are going to be positive numbers, but all of the y's are below the origin or below 0, so the y coordinates are negative. So every point in quadrant 4 has a positive x but a negative y. Okay. Now we're going to go through and name the coordinates or the ordered pair for each point and then tell what quadrant the point is in, whether it's 1, 2, 3, and 4. Now if the point is on the x or the y axis, we just say is it on the positive or negative part of the x or y axis. So if it's on the axis, it's not in one of the quadrants. So the quadrants do not count when a point is on the axes. So if we look at A, if you notice, we have to go, so we start at the origin, we move 1, 2, 3, but actually since it's left, it's -1, -2, -3 for the x, and then we go up. Once we move up, you start from 0, count 1, 2, 3, 4, so the point is -3, 4. Now the quadrant, if we see it's over here, we can also check the x is negative, the y is positive, so we know it's going to be quadrant 2. So we use the Roman numeral 2. For point B, if you see you start at the origin, we have to go 1, 2 to the right, so the x is positive 2, but then we have to move 1, 2, 3 down, so the y is -3, because anytime we're below the origin, the y is negative. And if you notice, well, this is quadrant 4, or you could also think, oh, the x is positive and the y is negative. So we know this is quadrant 4. Okay, C, well, since if I move left or right, I won't be able to get to C, so I know the x is 0. Okay, so basically you think of it as you stay put. But we do have to go up 2. So when we go up 1, 2, the y is positive 2. And remember we said if it's on one of the axes, it's not on the quadrant, so we're just going to say it's on the positive y-axis. Okay, it's positive because it's above the origin. D, we know we have to go over 1, 2, 3 to the right, so we have a positive 3 for the x, and then up 1, so the y is positive. And if you notice, both the x and the y is positive, so quadrant 1, all the x's and all the y's are positive, so this is quadrant 1. Then point E, if you start at the origin, we have to go left 2, so that means the x is -1, -2, so the x is -2. Then we have to go down 1, 2, 3, so the y is -3, because any y below the origin is negative. And if you notice, since it's in this area, it's quadrant 3, or you can even think of it as both the x and the y are negative, so we know it's in quadrant 3. And then point F, it might be hard to see, it's on the axis, so we have to go right 1, 2, 3, 4, 5 to get to F, but we don't have to go up or down, so the y is 0. And remember, we said any point that's on the axes, it's not in a quadrant, and we just say, okay, is it a positive or negative side of the x-axis, since the x is the horizontal? Well, we know that positive 5, we're just going to say it's the positive x-axis, okay? All right, so now we're going to actually be graphing functions, okay? Now, remember when we talked about function notation where we plugged in the x, like it would say instead of y equals 2x minus 3, it would be like f of x equals 2x minus 3. Well, when we do a table, basically it's the same idea, except we're going to be plugging in x's, different x's each time, 4 different x's. I'm just separating it into 4 areas to do my work. So basically I'm just going to use the same equation 4 times. And the first time, I'm going to plug in x is -1. The next time, I'm going to plug in x is 0. Then x equals 2, and then x equals 4. So I can find the y that goes to each one of these. So we use the same equation. I don't care if you're using this or this, the y equals 2x minus 3. In fact, let's just use the y equals 2x minus 3 since we need to find the y anyways. And those of you that have had Algebra 1 and you're good at graphing, when you plot these points, don't draw a line through it because the domain is not all real numbers. When we start next unit graphing slope-intercept form, that will have an all real numbers domain. Here we just have 4 separate specific x's, which means we're going to have 4 separate specific points. Okay, so let me show you. Basically, first, when x is -1, we're going to plug that in, and it looks like y equals 2 times -1 minus 3. Now we just do the order of operations, so we do the multiplication before the subtraction. So y equals -2 minus 3, and we know we could do keep, change opposite if you need to, or just know that -2 minus 3 is -5, which is the same thing as saying -2 plus -3 is -5. So right here, we know the y is -5. I can go ahead and plot that point right away. So -1, -5, boom, there's the first point. Now I love plugging in 0 because anything times 0 is 0. So when we plug this in, well, y equals 2 times 0 minus 3. Well, 2 times 0 is 0 minus 3. Well, that's just -3. So that's very quick to calculate. So here we plot the point, well, 0 means for x, we don't go left or right, we stay on the origin, but then the y is -3, so we have to go down 3 and plot our point. So there's our second point. Now we go back to the same equation, but this time we plug in +2. So we get y equals 2 times 2 minus 3. Well, that's just 4 minus 3, which is +1. So we have the point 2, 1. So when x is 2, y is 1. So we go over here, +2, and then we go up 1. Okay. The last one for this problem, we plug in y equals 2 times 4 minus 3. Well, that means y is 8 minus 3, or y is 5. Okay, kind of a messy y there. So then here we plot the point 4, 5. So we go from the origin, 1, 2, 3, 4, and then up 5, 1, 2, 3, 4, 5, there's our point. And there is our, basically our function, because for every x, we're going to have one y, and there's our 4 points. Okay, now let's review fractions. Okay, again, remember the goal by the end of this, hopefully year, but even this semester, is that I want everybody to see a fraction and think, oh cool, I can do this. It may take a little extra work, but I know how to do this, okay? So this time we're plugging in -4, 0, 4, and 8 for this problem. Now notice every problem, it might have different x's, so you just look at the table and it tells you what you're gonna plug in each time. So we know that since the x's are different, we're just gonna use these. And I'm gonna use a separate sheet of paper to show your work. So believe me, I'm expecting for complete notes, I expect to be able to see all the work for each of these tables. So like for number 2, we're gonna first plug in x, oops, I said y. We're gonna plug in x is -4. So what that looks like is we use this and we say y equals 3/4 times -4 minus 2. And if you remember, anytime we multiply a whole number times a fraction or an integer times a fraction, we just put it over 1. And in fact, I can divide first before I multiply. So I can divide 4 into -4, that's -1. And now, since both denominators are 1, I don't even need to worry about the denominator anymore. It's gone. We're just going to deal with the whole integer. So we have 3 times -1 is -3 minus 2, and we know that that's -5. Now, if it's easier for you to do the keep, change, opposite, and if it's easier for you to calculate -3 plus -2 to get -5, go ahead and do that. If you don't need to, don't worry about that. So this is -5, and then we have the point -4, so we go 1, 2, 3, 4 in the negative direction. Oops, I don't need my point yet. I still have to go down 5 for the y. Then I go down 1, 2, 3, 4, 5 to get to the point -4, -5. All right, so the next one, I'm going to plug in 0. Now, frankly, oh God, like I said, I love plugging in 0 because I don't even have to think about a fraction times that. I just know that a fraction or any number times 0 is just 0, so you get y equals 0 minus 2, so y is -2. Plugging in 0 is the easiest possible calculation you could ever do. So then we're going to go 0, which means we don't go left or right, we stay at the origin, but the y is -2, so we go down 1, 2, here's our point. Okay, now let's plug in x is 4. So we're going to get y equals 3/4 times 4 minus 2. Just put the 4 over 1. And beautiful, 4 divided by 4 is 1. All I have to do is multiply 3 times 1. That's just 3 minus 2, which I know is 1. So now I plot the point 4, 1. So I go positive 4, 1, 2, 3, 4 on the x, and up 1 for the y, and there's my point. The last one I plug in 8 for x, so we get y equals 3/4 times 8 minus 2. I put the 8 over 1. I can divide, it's always the bottom number into the top. So 4 divides into 8 twice. So all I have to multiply, since the 4 completely divides in, both denominators are 1, so I only need to worry about the numerators. So I have y equals, well, 3 times 2 is the whole number 6, minus 2, I know is 4. So then I plot the point 8, 4. Well, notice, if we go to the right, 1, 2, 3, 4, 5, it stops. Well, not a big deal. If that ever happens, just extend your x-axis, and then we know that, so if this is 5, so 6, 7, 8, I'll just go to 8, and then I go up 4. And then I just can count, if I go up 4, it's about here. Boom, there's my point. And you're done. Okay? Now, if you look at number 5, I want to focus on that. Remember when we talked about if there's ever a negative in front of the variable, we know that this means -1 times x plus 1. And you have to multiply by the -1 before you add 1, okay? Now, we're going to plug in these x's, and let me just tell you. So, first, x equals -3, right? So we get y equals -1 times -3 plus 1. Well, -1 times -3 is +3 plus 1. That's 4. So then I plot my point. I go to -3 and up 4. There's my first point. Then I'm going to do x is -1. So we get y equals -1 times -1 plus 1. A lot of ones. But -1 times -1 is +1 plus 1 is just 2. So I go -1, 2. And again, remember I love plugging in 0. So here x is 0. I get y equals -1 times 0 plus 1. Well, guess what? This equals 0. So if you just mental math, 0 plus 1 is 1. So that's easy, okay? In fact, a little tip, if you know that you're plugging in 0 for x, the x term basically equals 0, and it's going to equal the constant. So then we have the point 0, 1, which means the 0 for x, I don't go left or right, I just stay put, and I go up to 1 on the y. And then the last one, x equals 4, well, y is going to equal -1 times 4 plus 1, so y is -4 plus 1. We know there's more negatives, so there's -3 for the y. So I go to +4 on the x and then -3 on the y, and there's all my points, okay? Now, before I have you pause and do 1, 3, 4, and 6 on your own, I want you to look at the second page where this time, instead of a graph or a table, they're giving you the domain. In other words, remember domain are the x's. Okay, this is the new vocab in the previous. And then we need to find the range. Well, remember the range are the y values, okay? And one way I keep domain and range separate so I don't confuse them, well, since domain is alphabetically before range, it's the same thing for x's and y's. Well, x goes with domain just like both x and domain are first in the alphabet before y and range, okay? So that's how I remember them. So basically, like in number 7, they only have 3 x's listed. So I only have to plug it in to this equation 3 times. Here there's 4 x's, so I have to plug it in 4 times, and I have 4 y's. And because they didn't say to graph it, you're going to find the range is your answer, and you're going to use curly brackets and just put them in order as you find them. Okay? So basically, it's the same thing that we did before on 1 through 6, however, you're just not going to graph it. So, in fact, let's do number 9 together. So we're going to plug in x is -2 first. So we use this equation, and we get y equals 4 minus -2. Remember when you're plugging in a negative to use parentheses. Then all we need to know is, okay, well, subtracting a negative, it makes them positive, and y equals 4 plus 2 is 6, okay? Then, when we plug in x is +3, we get y equals 4 minus 3. Well, we didn't really need the parentheses, I guess, but 4 minus 3 is 1. And then the last x is 5, so x equals 5, y equals 4 minus 5. Well, if you want to do your keep opposite, or keep flip opposite, I don't know, everybody, or KFC keep change opposite, or flip, I don't know. You can do that, and 4 plus -5, you see there's one more negative, and you subtract, so it equals -1. So our final answer is going to be the range is the set containing 6, 1, and -1. Okay? So that's all you have to do. And you're going to end up doing them with fractions as well. So go ahead and pause the video and basically do the problems that I didn't do to check to see if you understand how to do this. And bring any